This lecture today is on tornadoes. Tornadoes are violent windstorms that involve rotating columns of air that extends down from a cumulonimbus cloud. These are low pressure based internally, where air rushes into the tornado, and it's typically counterbalanced by air that's falling out of the air mass, the cumulonimbus cloud itself. Winds can approach 300 miles per hour. By far and away, the strongest winds on the planet are found within tornadoes, therefore the greatest pressure gradient force. And some powerful vortices can form even inside of these tornadoes themselves. The occurrence and development, there's about 770 per year in the United States. Tornado season is spring into early summer. The exact cause of formation or vortex is not known, so I don't want to make it sound like it's matter-of-factly, but there's some information that is known, and that's what we can discuss that. The conditions, they typically occur along a cold front, and they take place during the spring months. Large thunderstorms that are supercells can develop into tornadoes and large-scale widespread tornado outbreaks. And these are associated with cold fronts that are moving very high speed and that are influenced by the jet stream or upper level winds. And then lastly, associated with cumulonimbus clouds. So there's some predictable characteristics or traits of tornadoes themselves. Here, just kind of the size of them. They typically move toward the northeast. I think that's an important one. We'll look at a map here in a few minutes. And they're measured by the intensity by the Fujita intensity scale. We'll look at that here in just a few moments. Here's kind of an internal cross-section where we get upward flow, we get downward flow, and we get the interaction that causes the vortex to form and mature. And you can actually have several different tornadoes taking place at one time. Storm chasers, love to see that. Water spouts, we get tornadoes on bodies of water. Those can take place. Here's a picture that's trying to illustrate what happens when you get air rising and air sinking. It creates a vortex, a spiraling of air. And then once it touches ground, then it's very, very powerful, extremely high pressure gradient force. Not that large per se, but they do a lot of damage. Here's a picture. You'll want to take a look here and read this. Here we have a low pressure system colliding with a high pressure system. So we have this cold, dry air from the continental polar colliding with the maritime tropical air. And these are perfect ingredients when you counter in the jet stream, high level winds that are just kind of shearing the upper levels. You just create rotation, and that drives them as well. Here's the annual tornado incidence per 10,000 square miles over a 27-year period. And we're noticeably, we're up here in the roughly 5 tornadoes per 27 years, and we've actually had a couple even in the last several years. Notice tornado season, we've got kind of late April, it starts picking up, May, June, and then it starts falling again. But here's July, and July isn't exactly, it's not exactly zero. The paths, I want you to look at the average path vector. They're typically kind of moving northeast, and there are a few that don't necessarily follow that perfect pattern, but the majority, by far and away, are on the ground, and they can be short duration. The longer the vector, the larger or the longer amount of time or the duration in which it's spent on the ground. Notice tornado watches. Tornado watches are just kind of saying the conditions are favorable, but a tornado warning says take cover. That something has been spotted, something's been sighted. You need to pay attention to what's going on and listen for further information. And this is typically followed by Doppler Radar, and local weather stations do a nice job of keeping the public in the know. So moving on, I do think it's important we make sure we identify the Fujita intensity scale, and this is what will define how powerful a storm is. So they're typically identified as, what's the F scale? So we've got an F scale with little to minor to roof, walls, just different amounts of damage. And so a small f, and then we've got a capital F, and this is kind of your wind speed factor. And F5s can be completely devastating. That can reach 300 miles per hour. And very, very powerful. So you've got kind of this relative scale, and it tries to kind of give you some perspective of how much damage can be done as it touches ground and just completely devastates areas. So a quick tornado review. We get this vortex that forms from rising and sinking air. The column of the vortex reaches down. Once it reaches ground, it does tremendous damage. Can be in and around the cumulonimbus cloud itself. We've got all kinds of air kind of rising and moving. This is typically the mature phase of the cumulonimbus cloud. The geography of it locally, we are in an area that does get its share of tornadoes kind of rolling through. Here's Tornado Alley. We get definitely Texas and North Texas and into Oklahoma, into this panhandle here, panhandle of Oklahoma. Very, very common tornadoes. And also Florida, this area of Florida where we find the severe thunderstorms on the map earlier. You also find a large number of tornadoes as well. And last but not least, the path in which they travel in Illinois is typically kind of northeastern. They move to the northeast and they come from the southwest. But once again, not everyone. Here's one, here's a couple that don't. And the vector itself, the larger the vector, just means it was on the ground and doing its thing.